Hello and welcome everybody to a new video. So this is the second video in my new series where I'm documenting my experiences with learning a little bit of Rust, and I'm writing a few different applications to do different things all around Rust. Part of the goals that I said in the last video with this stuff is that I always need to have some actual projects to apply these to, useful things, so that I'm able to really dig into it. And so part of that, we're following up with what we were looking at last time. So, as a reminder, if you haven't seen the last video, link in the description, um, we were working on some custom code that I'd written a while ago, which was written in Ruby. And the purpose of that code was to take some raster data of mountains, and it was to basically run an algorithm on it to generate contours, kind of abstract contour maps, and then it was going to generate G-code so that those could be engraved by my CNC machine. So not something that's at all niche, but if you follow my channel for a while, you'll find that I tend to dive really deeply into incredibly niche things sometimes. So this is another one of those. So this week, so I said at the end of last week that one of the purposes of bringing this into Rust was that I wanted to actually combine together a few different apps that I'd written over the last year or so, all of which were in some way generating G-code to do something programmatically based off of something that I was doing. And I wanted to bring that into one place and then try and abstract the G-code out to like a library where I could make it relatively generic and also be able to reuse it for different projects in the future. So I have lots of projects that I want to do that involve, generative art and stuff where I'd basically be writing some code to come up with some, geometry programmatically, and then I'd like to engrave that using my CNC machine. So I need something that can generically and easily generate G code for me, and so that's what I'm doing here. So I did this for the contour maps code. I implemented it in Rust, talked a little bit about that, wrote a really bare bones thing to drop it into G-code file so I could test it. But really what I wanted to do is abstract that G-code out. So to do that, I kind of had to implement a second app, which is fine because I had the code to do it written in Ruby as well. So what we're going to talk about today is just a little bit about that app. It's not super interesting, but it's kind of cool. And then how I took it and took what its G-code requirements were, because it had slightly different, subtly different G-code requirements. So combining those two together was my seed for what my generic implementation of this G-code generator would be. And that's what we have. So let's jump into it. So the first thing I do want to talk about is I talked about having two apps built into this, but we're still using the same. We're still using the same single repository. So it's basically, it appears to be like a single app. But one of the really cool things that you can do with Cargo, which is Rust's package manager stuff, is that you can, in one code base, you can define multiple different binaries to output when you build an app. And also you can define a library to be exported as part of that same repository as well. So this is quite cool. So I have one repository with loads of code in it that's outputting a library, and it's outputting two binaries. So that's pretty cool. And of course, two of those binaries reference the one library, and I can use the shared code between them, which is quite cool. So effectively, I have two applications being outputted from this that use common code that's defined in the library. So yeah, that's pretty cool. And that's something I'm just going to point to really quickly here. I don't want to dive too deep into cargo and stuff because I don't hugely know how it all works, but I'm just going to point to a few things. So this is the root of our repo. I've called it rustcam. And if we go to here, the cargo dot, I think it's called a toml file. It's like YAML, but toml. Anyway, this is our cargo config file in here. So you define the package. So I said that the package is rustcam. I've given it a 0.0.1.0 version. Then we'll skip over some of the rest of this. But yeah, the main points here I wanted to highlight was that you can define, so you have all your dependencies down here, which is fine. That's all managed by Cargo, external dependencies. But this is the real point that I think is really cool, is that in here I can define these two binaries. They're an array of arrays for some reason. That's just how they are. And these are basically, you define the names for these binaries, what they're going to be, and then you give them a path to the root, which is basically like the main entry point for the binary. And that's it. That's all you have to do. And then when you build this in Cargo, it'll spit out the two binaries. Really handy. And the exact same thing then works for this with lib. Don't know why it's different. Someone can explain that to me if they want down in the comments. But yeah, you give it a name and you give it an entry point to like the root of that library, and that's it, which is really handy. I suppose it's the module root, I suppose, for the library. And yeah, that's basically all you have to do to get the different binaries and libraries code all packaged up nicely. So like Cargo, it's cool. That's about as easy as I've ever seen this done anywhere, which is pretty nice. And then, yeah, quick one. You can look in the targets, which are the temporary folders for the build and stuff. Go to release, and you can see down here, I've got a binary called contour plot. I have a binary called Spotify codes, and I have this or.orlib for which is lib rustcam, which is the kind of standard naming convention. If you have a library outputted as part of a package, it gets the package name prepended with lib, and that's it. So yeah, that's pretty awesome. I really like that. So let's have a little look at what the new app that I built was. So this is the Spotify codes app. So I have this in here. Doesn't do a huge amount. It's quite short. It's got one kind of external thing here, an SVG parser, and then it has some code that generates the G-code, which I'll dig into a little bit later when we look at the library. But yeah, the main part of this, basically what this does is, if you've not seen a Spotify code, Spotify have these things where it looks sort of like a barcode. It has their like logo on it, and it sort of looks like a wave, like a musical sound wave thing. And basically you can generate these, and then you can scan them with your phone while searching in Spotify, and it'll open Spotify to that song. So I made a few of these for my friends as some last minute Christmas presents. But what I had to do was, I knew I could download the SVGs. That's readily available. So I knew if I could take the SVG, I'd need to parse the SVG, generate some G code from that SVG to engrave into little pieces of wood, which I then cut up and made into little key rings for some of my friends. So you can see, if I go to the Spotify codes, oh, that's just a raw SVG. I was hoping can I not show a preview of that? Oh, no, apparently not. Anyway, I can open it in a browser. How about that? Open with, doesn't matter. You'll figure it. You guys can figure it out. But yeah, we have an SVG. No, do you know what, Ian? Do it right. Let's do it right. Please bear with me. There we go. Okay. Now can I just drop this into this? Oh my god. Why is that not loading it? Oh, it's not gonna notice that it's an SVG. Hold on 1 second. We'll try another one real quick. There we go. Oh, is that why it wouldn't render here? No, try again. Hey, there we go. We got there eventually. So that's what a Spotify code looks like. This song happens to be Rap Snitches Knishes by MF Doom. This was my first testing one. So basically what I did was, my G code was going to be generate these bars, and I removed the Spotify logo. There's some terms and conditions around these where there's something to do with Spotify logos. You're not supposed to pay for these. If you sell something that has it on it, they're meant to be used for marketing or something. I don't know. Anyway, I removed the Spotify logo. So I just have these bars. Who knows? They're just bars. But if you scan them with Spotify on these keychains, it still works. So anyway, I'll show you what this app outputs then. So yeah, I'll leave that. Let's have a look at what the app outputs. So yeah, anyway, sorry. I'm going to read this SVG. There's some cool code here. There's an external library just called SVG in Cargo. Basically, I go down here. I find all the rect paths, which are just these rectangles that define the bars. I'm going to turn each of those into basically just a straight line that'll be engraved and then painted so that it has a thickness that you can scan. And then the only other thing I do is effectively where I'm in the place where this Spotify logo is, I'm just going to have a circle, and then I drilled through that circle to make the loop for the keychain to go through. Um, so that is what I mentioned earlier on. We had some subtle differences in the demands of the two apps. So the first in generating its G code. So the first app, the contour plots, just only ever needed to draw straight lines. This one needs to be able to draw curves. So in G code, you can draw an arc natively. So I should also say in Gerbil G code, which is what we're implementing this for, effectively you can only do two really interesting things. You can generate lines and you can generate arcs. So arcs can draw circles and they can draw, curves between 2 points. You give it a radius and a direction to move in, and it'll draw an arc for you. So that can draw a circle. Start and end point is the same. It'll go around and do it. So those are the differences it had. So I'll run it quickly and we can see what the output is. So actually I need to rename this one back to being just test, or else the code won't pick it up. Okay, and then I can run that. Spotify codes. Oh, yeah, has to compile it first. And why is that taking? Oh, it took ages to compile. Don't know why that took so long to compile. It runs very quickly though. Oh, yeah, there. Very, very fast. It just took a while to compile for some reason. So if I copy out this code, I'm gonna go to what's it called? NC viewer. Copy in the G code. Let's have a look. Oh, good. Well, that's at a funky angle. Oh, there we go. Yeah. There. Okay. That's what it generates anyway. You can see the circle and then all the lines drawn out. And that's what the CNC machine will engrave. So yeah, that's about it. It's kind of cool. It's fun. I think I did publish a YouTube short on the little process of making these back when I did it just before Christmas. They were last minute Christmas gifts. I'll link that down in the description as well. You can see it if you just want to see it doing the thing and how I painted them and stuff. They turned out really nice and they worked really well as well. So anyway, that's an aside. Okay, so I'm going to close this and we're going to talk now a little bit about the actual G code generation logic and the custom stuff that we had to do for that to make it work. So let's close these. And yeah, I think this is a good place to start with the README because I have the types basically listed out. This has been edited since, so I think I can reload that. There we go. README preview. That's not a preview. That's a preview. Close all this. Okay, so I can update this too. It's not under construction anymore. It actually does things. Anyway, the library code. So we'll look at the types because this is basically the main part of the logic of this at the moment has been implemented is just the types that model the different kinds of movement. To note, there is still loads of hard-coded stuff in here that's very specific to my implementation. I've got like feed rates, how fast it can move, hard-coded. I've got the Z heights, hard-coded to basically be a very particular engraving depth that works with my setup, as in the bits I'm using and the material I'm using and stuff like that. So loads of stuff that needs to be made configurable, which I will do. That's all on the list to do. But the first thing I needed to do was basically be able to abstractly model moving the cutter to some place to start a tool path, like an engraving path or a cutting path, and then pick it up and move it somewhere else. And within those, basically within those tool paths, so we'll see this later on as I talk through them, I needed to be able to draw straight lines and I needed to be able to draw curves and arcs, basically. So that's what the purpose of this modeling is, and we'll go through it a little bit. So first and foremost, simplest thing, we have a point. So a point just represents XY coordinate. Within this, we assume we basically forget about the Z. Say if we're engraving, we're just going to be at one reference plane, which is one Z height, which will move around for clearance and stuff like that. But assume that the actual everything that gets stitched together for how the machine moves, how it cuts stuff, is all going to be on the same Z height. We could change that in the future. This doesn't limit us. It's just for now, it's a simplification. So we have points. I'm going to come back to what the segment means and why it's important, because that's probably one little nugget that you might get out of this in Rust, which is kind of cool. Anyway, we'll move on. We have lines. So a line, very simple, it has a start point and an end point, because that's all a line is. Well, a line segment, if we want to be very mathematical about it, I'm just calling it a line. And then the second kind of, basically these are both sort of movement types of movements that the machine can do, like any cutting movements machine can do. We also then have an arc. An arc also has a start and an end point, and it has a radius and a direction. So basically this is very simple. You start here, you end here, and then there's some curve that goes between the two that has a certain radius, and also has a direction. So this makes sense if you think about, if you have 2 points here and here directly above each other and you draw a radius between them, you could go that way or you could go that way and it'd be the same. Well, the radius would be the same, the start and end point would be the same, but they're two distinctly different arcs. So the way we can model that is by this Boolean direction, which tells us whether it's anti-clockwise or clockwise, and that's it. And this models to how it's done in G-code. Simple. So the last piece of the modeling is what I call a tool path. So if you're familiar with CNC and all that sort of stuff, you'll know what a tool path is. But this is a slight abstraction. Basically what I've said is that in my system, a tool path is any time when the tool basically is introduced into the work and moves continuously through the work and then will lift up again. That's what I've defined as a single tool path. And a single tool path can be made up of loads of different chunks. So in this case, segment, we'll come back to that again, as I said. Segments are effectively going to be lines or arcs. And the only thing with them is that this system assumes that they're contiguous. So that if you have multiple segments, multiple lines, you might remember this, similar to the logic from the contour map video, the start of one is going to be the end of another one, so that you stitch them together basically so that they're contiguous, so that when the cutter goes into the work, it can move between all of them, and there won't be some travel move that leaves a big scratch on the work because the cutter didn't know it had to lift up. That's basically the crux of it. So you can have a whole list of toolpaths that you generate G-code for, and between all of those toolpaths, there will be the cutter will lift up, move to the next toolpath, drop down, cut the path, lift up, move to the next one. That's how it'll work. Okay, so with that in mind, actually, that's basically the main method of this is this generate G-code method. Oh god. And what the generate G-code method does is it accepts a vector of toolpaths, which is this set of toolpaths, like I said, and it takes them one after the other, and it will generate the G-code for each of those with a movement in between. And then the very final thing it does, it also encapsulated the logic to write the G-code out to a file in this, because both the contour plots and the Spotify codes code did this themselves, so I just threw it into the library as well. You wouldn't have to use it, but it's there. Okay, so with all that said, let's talk about this segment thing and why it's important. So this is a trait in Rust. So this is where you have to think a little bit about the kind of type system that Rust employs and how it's different to type systems in other languages. So if you're familiar with object-oriented languages, and there's the idea of inheritance where you've got like a parent object and then child objects that are derived from it, and people would often use those to model, could use that to model something like this. So say in here, I have a list of segments, but a segment could be anything. But I know that all my segments are going to have a certain common functionality that they both have start and end points, say, and you can draw between them. You either draw a line between them or you draw an arc between them. But effectively, it's the same thing. You're doing something. You're generating some movement of the machine based on what that is. But you want to be able to have them one after another, and you want the code to obviously accept that, even though they're different things. So in an object-oriented language, you might define a parent, say a segment, maybe an abstract class, a segment where it can't be instantiated, and then you would say that a line is a segment and an arc is a segment. So this is a relationship where it's like this parent-child hierarchy thing. And then what you would do is here in your toolpath, you'd say segments, and you'd have an array of segments, and you'd be able to call anything on that that's common to both a line and an arc. And that's how you could model something like this in object-oriented languages. Rust and its type system does not support inheritance. So Rust, similar to Go, uses this kind of arithmetic typing. So as opposed to thinking about is-a relationships, you're going to think about has-a relationship. You can also think about this sort of has-a relationship, like these trait things, a little bit like interfaces, where they define common behavior that things should have, but don't define how it does it. So you have to define how it does certain things. So in our case, I'll show you the code of how this works. We define a trait. This trait I'm calling segment. So anything that implements this segment behavior will implement a method called generate gcode, which will spit out a string. So basically what this will do is when you call generate gcode on a line or an arc, it'll spit out a string. In my case, that string represents the gcode that should be executed for that object. Okay, so let's look at the code to see if we can understand a little bit more about how exactly that works. So we go to my lib and we'll look at our type system. So we have our segment here, which has this generate gcode method. And as we scroll down, we'll see we have our line, our struct line. And then here we have this piece of code. So it's impl segment for line. So this tells us that this is my implementation of the traits of the trait segment, which has methods on it, for the struct line. And I have the same thing down here for arc. And in the case of what this actually does for a line, it's really simple. It outputs a string where it's going to output this, basically x, y, and it's going to have the end coordinates, the x and y. So the line end coordinates, and that's how I've determined this should work. Equally for the arc, does a similar thing. It has generate gcode method, and it uses the direction, because this will define whether it's clockwise or counterclockwise. In gcode, that's G2 versus G3. So either of those commands will either draw a clockwise or a counterclockwise arc. You define the x and the y, and I, in this case, is the radius, and that's it. And then again, this is an example of some more hard-coded stuff I have in here. The feed rate specifically hard-coded. I would want to make that configurable eventually. So that is basically the guts of how this is able to know that it has two different types of things that it wants to be able to do and how it puts it together. So I can show you then what the code actually does. So the main body of it. So this is again a load of hard-coded stuff which you'd ideally make configurable, but it takes this list of toolpaths. In between each list of toolpaths, it says it does a travel move to the first point of that toolpath, and then from there it goes through each segment that's in that toolpath. It calls the generate gcode function, and then it stores that in a list. And that's this big list of gcode commands, which ultimately it returns, which is just a list of strings, and then I can get it into a file or whatever. So what am I missing here? Oh yeah, so there's a slight nuance with how the type stuff works. So this thing, you might have noticed that it's not just in the type definition. It's not just a segment, a vector of segments. It's actually a boxed. It's actually a vector of boxes of this dynamic segment trait thing. So this is a little bit, I'm not going to talk to this very well because I'm probably going to get it not 100% right. But basically, box in Rust is similar to the concepts that exist in other languages. So in Go, they have a pointer system that enables you to do this, and in like Java and C#, they have the the concepts of boxing and unboxing. And basically, it's to do with moving things from the stack and the heap and references between them and stuff like that. So because Rust is very opinionated about its memory management, you can't just have a list of this like, well, also I want to say abstract type or interface, but they're not even the same concepts. But you can't directly have a list of these traits. What you can have is you can have this boxed memory thing, which all you're saying is that whatever comes out of this box, it implements, or yeah, it will have an implementation for what a segment means. Kinda, basically. It has lots of uses, but in this instance, how I've been able to leverage it is that I'm able to have effectively a list here of different types of things. I can have a list of lines and a list of arcs, and I don't have to distinguish between them because I know that they have both implement the trait of segment. When my code gets called here, it returns this box thing, and on that, because I know that it's this dynamic segment trait thing, I'm able to call this method on it, and it will just work basically. So yeah, it's a little bit weird, but that's effectively how you can do this sort of abstract typing thing in Rust. That was something I learned for this. Didn't know exactly how I was going to approach this. Knew there was some sort of way to do it, and this is the way I've arrived at doing it. Might not be the best way, but it's a way, and it works in this instance. I'm pretty happy with it. So, and I learned something by doing it, so that's always positive. Yeah. So I don't want to talk too much more about this because this video is running on enough as it is. I hope you enjoyed it. I hope maybe some of the concepts are interesting. I hope if you have a particular interest in like CNC and stuff, this is like made you think a little bit about, well, how would you generate G-code, or how does my CAM package inside Fusion 360 spit out the G-code? What does it do? Maybe it definitely doesn't do this, but it might do something sort of similar to it. So it's just an interesting thing to think about. Yeah, so I'm gonna leave this here. I have more Rust plans, more projects planned. I'm going to move away from this specific app, I think, for the next project. But I have a little project in mind that I think is going to be fun. Slightly different tack, but it's still going to be Rust and me learning Rust, basically. So yeah, I hope you guys enjoyed this. And yeah, check out the repo, link in the description if you want to see the code and stuff. And yeah, I'll see you guys in the next one. Thanks for watching.